Okay, now we're going to talk about Lab 9. That's right, Archimedes' principle. Now, what was Archimedes' principle? Was that the guy that was in charge of Archimedes High School? No, Archimedes didn't go to high school because they didn't have high school when he was around. But he's the guy who discovered this, and it's about density. Now, who was Archimedes? Well, he was this guy who was around about 300 BC or so, and he discovered a lot of principles about physics and math and so forth. He was a brilliant guy. One of the stories about him is that the king of Syracuse, and I'm not talking about the city in New York that has the college with the basketball team, I'm talking about Syracuse, which was a city in Sicily. He had just got a new crown made, and it was supposed to be pure gold, but he thought that the guy who made it put in some silver. Follow me. Put in some silver. So he wanted to know if there really was some, if it was all gold or some silver, whatever, but he liked the crown and he didn't want to destroy it in the process. So the only way he could think of to do it was to melt it down and figure out if he had gold or something there. So he asked Archimedes to figure it out for him. Now Archimedes was thinking about it. He couldn't figure out how to do it. Well, anyway, one day he's taking a bath. It must have been bath day that year. The public baths in Syracuse. And he saw that as he got into the bath, all right, the water went up. And he figured out, from that I can figure out the volume of the crown. And because he knew the mass of the crown, he could figure out the density of it. And because he knew the density of gold and the density of silver, he could figure out how much of it was gold and how much of it was silver. And he was so excited, he jumped up out of the bathtub and ran streaking through the streets of Syracuse, yelling, "Eureka! Eureka!" And somebody says, "You don't smell that great yourself. Get back in the bath." Oh, come on, that's funny. That's good. Yeah, let's get a little laugh out of him. Okay, no, we're not going to do that today. First of all, no, we don't have any bathtubs. We're not going to do any streaking or anything like that. But we are going to dip things into water. Okay. So, by the way, it's interesting how Archimedes died too. Archimedes had built all kinds of weapons to defend the city of Syracuse from another kingdom that was trying to invade it. Really neat stuff. And what happened was the king, the other king finally snuck some soldiers in and they won. And the other king had said that he wanted Archimedes alive. All right? He didn't want, because he wanted Archimedes to design weapons for him. So the soldiers are out looking for him, and one soldier found him. And Archimedes was busy working out a problem on some sand in the front of his house. And the soldier was like, "Come on, you gotta come with me." And Archimedes said, "Just a minute, I gotta finish this physics problem." "No, you gotta come with me." And the soldier got so enraged because Archimedes wanted to finish his homework problem that he took out his sword and chopped his head off. So that's why you should always make sure you finish your physics homework before you come to class. Because you can't do it in class or else the soldiers might chop your head off. Seem to have lost the story somewhere. Anyway, okay, so that is the story behind the lab. Now we're going to talk about the lab itself. Now the lab itself, what we're going to do is we're going to use force probes. And I'm going to explain the theory behind this in just a minute. But for right now, I just wanted to go over the procedures in the lab. Now you all know how to calibrate and zero a force probe. Obviously, this isn't going to work the way I've got it right now. But because all you have to do with this lab in terms of measurements is you take a force measurement, you hit the collect button on Logger Pro, and you take the force measurement, and you take statistics on it, and you get good data, right? Okay, that's it. Well, in the first part, what you're going to do is you're going to be given an unknown material. Maybe an unknown like this. You're getting sleepy. Very sleepy. Oh, sorry. I hypnotized myself. All right. Okay, so what you want to do here, it's very simple. All you have to do is after you've calibrated, you put it here, and you get the weight. Remember, weight is a force, not the mass. You get the weight of the object in air. Now focus here, down here. And then you put it in here, and you be careful. You make sure that the weight doesn't hit the sides, because you'll mess up if you hit the sides or the bottom. And you get the weight of the object in water. Very simple. Air, water, air, water, air, water. And from that, using the formulas I'll go over in a minute, you can figure out the density. Now, once you have the density, this is on part 1. Actually, I did part 2. I'll go back to part 1 in a minute. This is part 2. Once you have the density of any of these materials, there's a website you can go to figure out what material you've got. Now, the website has all different kinds of materials on it. So, you will have to be able to recognize which material makes sense for what you've got. For example, if you get something like this, and you weigh it, you do all your work, and you find out that you have solid nitrogen, well, chances are you're wrong. This is not solid nitrogen. Nitrogen is not a solid at room temperature. If you get that you've got platinum, well, let me clue you in on something. We didn't blow the entire physics department budget on a couple of unknown objects, all right? No, it's not platinum. It's not going to be really expensive. If you got something like uranium or plutonium, well, chances are we didn't get anything that was toxic either. So, no, we didn't get it toxic. That's probably wrong too. In fact, if you've never heard of it outside of chemistry class, well, you're probably wrong too. So if you get all of those combinations, like for example, if you guess terbium, which is toxic, expensive, and you've never heard of it outside of chemistry class, well, that's a real good indication that you're wrong. Usually you're going to be off by a little bit, so you got to look around where you get. And if you see, all right, let's see, I've got terbium, plutonium, gold, platinum, and iron, and let's see, francium, and nitrogen, and those are your choices, it's going to be something simple, isn't it? Like aluminum, or iron, or something like that, okay? Okay? Now, for the first part, we actually figure out the density real simple. On the first part, these are a little bit messed up. I will give you an object. You come up to my desk, and I will give you one of these objects, like this one right here. All right? Now, what you do is you take it back there, and you are going to measure the dimensions of the thing. It's good. I'll give you some calipers. You can measure the height, the length, and the width. Or the width, the length, and the height. Or the width, the height, and the length. Or the length and the height and the width. Did I say that one? All right, anyway, you measure all that, and you get the volume. Not hard, is it? Is it hard? No. Say they agree. You can't even see them, but they agree. It's not hard. And then you weigh it on a scale. Easy. Really straightforward. Okay? Now this is the important part. On the data sheet, which is all done in Word, there's no Excel spreadsheet for this one, okay? You have to make sure that you write the number of the object that you have. Each of the objects has a number. All right? You see this one here? Probably not, because I probably got it too close. Can you see what the number says? What's it say?
5.
Okay, so that's a 5. Each one of them has a number. Now you have to make sure that you get a number from the right pile. So that's why I have to make sure I give it to you. This one here is a 1. All right? And you have to make sure that you put that number down on your data sheet. Okay? Now part 2 I already talked about. That's where you use this one here. One of the unknowns. You can't figure out the volume of this. All right? And the fact that you can do it this way is kind of neat because of the way it works out, the math. And I'll show you that math again, like I said. Now, for the third part, you'll like this. The third part, we're going to use another object, and this object is going to float. The problem with the floating objects is they also... Jeez, stupid floating object. They make a mess. The problem with the floating object is they tend to want to hit the sides, and they're kind of hard to get the force probe to work right. And so what you have to do there is you can replace the force probe, the hook, with one of those rubber stoppers and kind of push it underwater. But you got to make sure you push it all the way under. Here, take a look. See, like this. You got to make sure you push it all the way under, and you got to make sure you don't hit the sides or the bottom. Okay? So now on those ones there, you also just have to, you don't have to, for part 3, you don't have to write down the sample number because you just have to describe it. Like for example, this would be wood. All right? It's not an unknown metal. I got to change that sheet sometime. People complain about it. This would be a cork. This would be a piece of styrofoam. And this one here, well, you'll find out about this one here. Okay, so that's part 3. Part 4, you use these brass parts. Now this is the part that people get a little confused about because some people will pick up one of these brass parts to do part 1. That's why you have to come up and see me. You bring back your parts you have and you get another part, okay? So for part 4, you get a brass part. And you measure, again, this is where you measure the sizes again, like that. Now you know, and I'll go over this in part 2 or 3, that brass is made up of only 2 things. What 2 things? That's right, zinc and copper. All right? Now how can we figure out, I'll just talk about it now. How can we figure out what percentages is zinc and what percent is copper, just based on the density? I don't know. Oh, no, I'm imitating you. I don't know. You can, it's easy. All right, this is exactly what Archimedes did. All right, except he used silver and gold. We don't have any silver and gold. Okay? Well, you know that the percentile, I'm going to use P, which is going to go from 0 to 1, of zinc, plus the percentile of copper is equal to what? What? Mark, do you know?
I wasn't paying attention.
Typical, isn't it? We know that brass is only made up of zinc and copper. All right? Well, this is 0 to 1. So what would it be? Like 0.75 and point. So the total is going to be equal to?
1.
1. Okay. We also know that if we take our percentile of zinc, multiply it by the density of zinc, which you can look up or I can give you, and we take the percentile of copper and multiply it by the density of copper, that rho, this thing here means density, that's going to be equal to the density of the brass you have. Okay? And then we have all of these densities. Okay? What we end up with is 2 equations and 2 unknowns. Okay? So we can take this, we can solve this top one for the percent of zinc, percentile of zinc, substitute it in here, and then calculate the percentile of copper. And then you get the percentile of zinc back. Okay? Does that make sense? Does that make sense?
Sure. Yes.
Yeah, speak up, guys. The people watching you. This is a famous YouTube video. There are going to be like tens of people who watch this video. Okay?
Go viral.
All right? So, let me see if I forgot anything. I don't think I forgot anything. I'll talk about the theory a little bit late on the next video, but I want to stop now here. That's how you do the lab, okay? So, I'll see you in the lab.